Assalamualaikum and hi everyone. My name is Muhammad Akib bin Ahmad Fazil and my matric number is F25A2075 and I'm a group leader for group 47. I have a keen interest in the intersection of applied bioscience and data driven management. Today, I am excited to share how we can transform traditional poultry farming into a intelligent system through poultry growth analytics. The central problem we are addressing is biological uncertainty. Poultry growth is detected by a complex array of variables, including genetics, nutrient, environmental stresses, and microbial health. Traditionally, management decisions such as feed timing or lighting duration have been largely reactive. We often only notice a performance drop after economic damage has already occurred. We need a system that shifts us from reactive management to proactive, data-informed decision making. Why is this study critical? Firstly, it's a matter of resources efficiency. Feed costs often for roughly 70% of total production expenses. By optimizing the feed conservation ratio, through analytical modeling, we can significantly cut costs and reduce waste. Secondly, animal welfare by using a AI-driven indicator to detect health issue early, we can intervene before a minor stressor escalate into a flock-wide health crisis. Finally, business business scalability. Data enables us to maintain uniform quality standard across massive operation, which is essential for modern enterprise management. It is our foundation by deploying IoT sensor. We capture real-time data on environment, behavior, and weight. In essence, we are translating farmers in institution into actionable numbers. Here we are apply mathematical frameworks such as the compass or logistic growth model to plot actual growth against ideal curve. This allow us to instantly identify if a flock is underperforming relative to its biological potential. This is the brain of the system. It doesn't just inform us of the provide specific evidence. It's just based on recommendation such as increase room temperature by 2 degrees or adjust nutrient density to optimize the come out. If you are developing this data platform in index, my recommendation to enhance the user experience is to implement interactive prediction visualization with tooltips. Instead of showing static charts, integrate a future style project line. When a user over a data point on the graph, use a tooltip to display a specific recommended action for the exact stage of growth. This effectively to dashboard from a simple monitoring tool into a dynamic real-time decision support system. This is how the flow for the if you are developing this data platform in Index, my recommendation to enhance the user experience is to implement interactive predictive visualization with tooltips. Instead of showing static start, integrate a future state project line. When a user hover over a data point on the graph, use a tooltips to display a specific recommended action for the exact stage of growth. This effectively evolve your dashboard from a simple monitoring tool into a dynamic real-time decision support system for the graph. That's all for me. Thank you.
Name is Wan Faris Rohambe Wan Asmadi. I'm from SFH Animal Husbandry. Metric number is F25A1430. And today I will present my project website titled Broiler Chicken Feed Intake Velocity Precision Poultry Technology. My project focused on the application of derivatives in bioscience, specifically in modern poultry farming. The aim is to use mathematical concept and technology to monitor the feeding behavior of broiler chickens more efficiently and accurately. So first, I will go through the introduction to the bioscience problem. The bioscience problem discussed in this project is the difficulty of monitoring broiler chicken feeding behavior accurately and efficiently. In many poultry farms, farmers still rely on manual observation to monitor feed consumption. However, this method can be time consuming, labor intensive, and prone to human error, especially when managing thousands of chickens. If chickens consume less feed than expected, their growth and health may be affected. On the other hand, excessive feeding can increase production costs and lead to feed wastage. Therefore, farmers need a smarter and more reliable system to monitor feed intake continuously and detect abnormalities as early as possible. This is where precision poultry technology becomes more important. So next, the importance of studying this problem. This problem is important because poultry farming is one of the major food industries in Malaysia. Feed costs account for a large portion of poultry production expenses. By understanding the feed intake velocity, farmers can make better decisions regarding feeding management and animal health. Monitoring feed intake can help farmers improve feed efficiency, reduce feed wastage, detect diseases earlier, improve animal welfare, and increase farm productivity. As a result, precision poultry technology contributes to more sustainable and efficient agriculture practice. So to the next part, derivative application in the project. So now I will explain the derivatives concept used in this project. The derivative is used to measure the rate of the change of feed intakes over time. The formula that I use is df over dt, where f represents the amount of feed consumed by the chickens, t represents time, and df over dt represents the feed intake velocity or the rate at which chicken consume feed. Okay, so this formula measures how quickly feed consumption change over a specific periods. For example, if the value of the if the value of the f over dt increases, it means the chicken are consuming feed at a faster rate. If the value suddenly decrease, it may indicate stress, illness, poor environmental conditions, or other health-related problems. Using derivatives allows farmers to analyze feeding patterns more accurately and detect unusual behavior earlier than traditional observation method. This demonstrates how calculus and derivatives can be applied in real-life bioscience and agricultural technology. As example, as you can see in my website, you can change the input and the formula here automatically change to your input. Same as the graph right here. If you change I will change the velocity growth constant. The graph also change following the input that you put. Okay, to the next part. I will explain about the graph. The graph represents the relationship between time on the x-axis and feed intake on the y-axis. This graph helps visualize how feed consumption changes throughout the observation period. When the graph rises steeply, it means the chicken are consuming feed rapidly. In derivative terms, the value of df over dt is high because the rate of feed intake is increasing quickly. When the graph rises gradually, feed consumption is still increasing but at a slower rate. If the graph becomes flat, it means feed intake is no longer increasing significantly and the derivative value is close to zero. And if the graph starts to decrease, it may indicate that the chickens are eating less feed than expected, which could suggest health issues or environmental stress. The derivative is directly related to the slope of the graph. By analyzing the slope, farmers can determine whether feed intake is increasing, decreasing, or remaining constant. Therefore, the graph not only shows the amount of feed consumed but also provides information about changes in feeding behavior over time. This allows farmers to make faster and more informed decisions to improve poultry management and productivity. Okay, so next, now I will explain the content and design of my website. As you can see on the home page, I introduced the concept of broiler chicken feed intake and explained the importance in precision poultry technology. This website also includes section discussing the bite size problem, feed intake velocity, precision poultry technology, derivatives application, and graph analysis and interpretation. This website is designed with a clean and organized layout to ensure users can easily navigate and understand the information present. I use suitable colors, structure content sections, and visual elements to improve readability and create a professional appearance. This website also published through GitHub pages, allowing users to access the project online. So next, my recommendation for improvements. One recommendation for improving this website is to add more interactive features. For example, future improvement could include real-time data visualization, interactive graphs, sensor simulation, and live poultry monitoring dashboards. This addition would make the website more engaging and better represent real-world precision farming system. And for the conclusion, these projects demonstrate how mathematics, bioscience, and technology can work together to solve real-world agricultural problems. By applying derivatives to analyze feed intake velocity, farmers can monitor chicken feeding behavior more effectively, detect problem earlier, and improve overall farm's productivity. This project also helped me develop my understanding of calculus applications, bioscience concept, and web development using HTML. So that's all for me. Thank you for listening to my presentation.
Good afternoon to our lecturer and my fellow peer. My name is Abang Afiq Safiuddin bin Abdullah Abang Zulkifli. My I from SFS. My metric number is 25A 2068. Today, I will be presenting my bioscience web project titled Our Microscopic Enemies, the Rise of Antibiotic Resistance. Let's look at the summary of the bioscience problem highlight on this website. Antibiotics are powerful medicines designed to kill or inhibit the growth of harmful bacteria. However, due to several factors such as the overprescription of drug, the misuse of antibiotic by the public, and patients failing to complete the prescribed course, bacteria have evolved. They have developed defense mechanisms known as antibiotic resistant. The very bacteria that we once easily eradicated have now transformed into superbug microorganisms that are immune to existing treatment, making common infection dangerous and incredibly difficult to treat. Why is it absolutely crucial for us to study and understand this particular bioscience issue? As detailed on the webpage, antibiotic resistance is not distant future threat, it is a crisis happening right now. If we fail to understand and address it, we risk everything to a penicillin era, where amino scratch or a routine surgical product procedure procedure could become fatal due to a great bacterial infection. By studying this problem, we can understand the biochemical and genetic mechanisms behind bacterial mutation, help the medical community spread accurate awareness regarding proper drugs usage, and next drive further bioscience research into discovering alternative treatment or novel antibiotic. And now let us navigate through the actual content and structure of this webpage. The introduction section, the top I ask a high impact title our microscopic enemies to instantly catch the user attention and emphasize that our biggest threat are invincible to the next year. Main point the cause and mechanism. As well scroll down, I outline the root cause of the crisis. I categorize them into critical points such as the overuse of antibiotic in livestock, vaccine not compliance, and poor hygiene in healthcare setting. Impact and consequence. Following that, this section explains the direct toll this take on the human immune system and how it strains global healthcare system, forcing hospitals to rely on much stronger, more expensive last resort antibiotic. Recommendation to make the hasty better as the developer of the page. I recognize that there is room for technical improvement regarding the HTML structure and user experience. My primary recommendation to make this HTML better to integrate interactive element using JavaScript of CSS framework like Tailwind or Bootstrap. For instance, I could implement an interactive accordion menu or flip cut for the section detailing the cause of resistance. This way, when I user click on a specific point, I detail breakdown smoothly expand. This will reduce text density on the screen and create a much more dynamic user experience UX. And last conclusion, in conclusion, this web page was designed not just to meet the technical requirement of our project, but to serve as a digital medium to educate the public of the growing danger and antibiotic resistant bacteria. The that concludes my presentation for today. Thank you so much for your time and attention. And I am now open to any question or feedback.
Assalamualaikum, good evening. My name is Ahmad Fakar Hadi bin Ahmad Rosli. Matric number F25B2089. And I am the editor of the project as well, a student of Animal Husbandry Technology. Today, I would like to present calculus can help cattle farm in Malaysia reduce feed costs and improve productivity through an application plate you can play. Feed is one of the large expensive in cattle farming and can account for more than half of the total production cost. Therefore, farmers need an effective way to determine when to provide high quality feed and when is the best time to sell their cattle. Most farmers monitor only the body weight of their animal. How- However, body weight alone does not provide complete information about growth performance. To understand this better, imagine a cow as a car on a journey. The cumulative weight of the cow is like the total distances traveled by a car. Why the total distance is important, what matter more is the speed and a particular movement. Similarly, in cattle farming, we need to know how fast the animal is growing each day. This growth rate is represented by the derived a compound in calculus that measures the rate of change a specific point in time. We commonly use this compared to analysis cattle growth. When weight data is shared, the system generates two graphs. The first graph shows the animal overall growth, while the second graph shows the growth rate over time. For example, at 1 2 months of age, the growth rate measures approximately 640 grams per day. The This indicates the fetus growth phase where muscle development is high activity. During this period, farmers should provide high quality feed, weight sufficient protein to maximize growth and meat production. Uh, of the other hand, at 4 months of age, the growth rate drop close to zero. This means the animal has reached maturity and growth has slowed significantly, although the animal continues to consume feed. The displacement in body weight becomes very small. As a result, farmers spend more money on feed while receiving less return from growth. We call Malay that farming identify the most profitable profitable time to market or sell their cattle based on scientific data rather than estimation. This project was developed using HTML, Tailwind, CS, JavaScript, Chess, and MathJet. A logistic growth model was used to represent the growth pattern of Kedah Kelantan cattle, while the derivative f prime of x was used to calculate the instantaneous growth rate. The system automatically performs calculation display interrupt graph. By clicking on the graph, user can displayly view the cattle weight, growth rate, and biological interpretation. In calculation in the project demonstrate that calculus is not only a mathematical theory in the classroom. Through thereafter, we can analyze, grow better, and apply this knowledge to livestock management. By understanding cattle growth rate, farmers can optimize feeding strategy, reduce unnecessary feed expense, and determine the best time to sell their animal. As a result, vehicle play as the proprietor to reduce feed cost by improvement 1.5 to 0% while improving farm pro- profitability. That is all for me. Thank you. Your attention. Have a nice day.